So hey everyone, welcome back, and today we are going to discuss another contest, and this one is weekly contest 514. And today we are going to discuss a few problems from this particular contest. The problems are really good, so without wasting any time, let's get started. So the first problem is minimum total price after applying discount. So let's see the problem. That you are given a 2 integer array prices and discounts. The value of prices represent the price of the ith item, and the discount represent a discount percentage. You may apply discounts subject to the following rules. Got it? Each discount can be applied to at most one item. Each item can be receive at most one discount. The same thing, an item may also receive no discount. Got it? If a discount of a d% is applied to an item with a price p, the final price become this, and the final price is not rounded. Got it? Return the minimum possible sum of the final process prices after assigning the discount optimally. Got it? So this is the result. So what we done? We take our discount 60 and apply 130 to reduce its value. Now we take a 50 and try to pick 21 to reduce its value. So basically what we are doing is, so if you see, so this is the example which they have used. So basically this is represented as prices of the items, and the goal is quite simple. We have to minimize the prices value. So in order to do that, in a normal, what you can do, try to use the discount on the maximum price. Got it? So this is it's the general thing which everyone should know, that okay, if I have certain price, right, what I'm saying, that if I have, let's say, certain price and I have to find the minimum from it, so why not pick the so I should choose the maximum discount on maximum price. So this is what I have to do over here. So if you see in the example what they have done, they have choose 60 for the item price is 30, then 50 for the 21, which means we are always picking the maximum discount for the maximum value. So this is the idea. And what's the formula they are referring? The new price is become, if we are applying the discount, which is p into 100 minus the discount divided by 100. So this is going to be new price of particular item. Right, so it's straightforward. We don't have to do anything else. Just remember one thing, we are using max discount for the max value. So for that we should need and prices and the discount as in a sorted order. So this is the one thing which we need to take care of. So let's see the code. It's pretty straightforward. And one more thing which they have mentioned, that the result price is not rounded, so we don't have to provide a rounded result. It will be accepted if we return a decimal value as well. So you see, I have sorted an array, and I explain you why. Because we are picking the max and price and max discount, right? And we are running from the another side, right? And at every point we are just picking that particular value and calculating the discount and moving our I and j pointer. And after that, if you see, there is not case that you see in the question they also mentioned that an item may also receive no discount. So it is possible that the discount length is not equal to the prices length. So in that case, whatever the price is, we simply add it to our result. So that's what I have been doing over here. So this is the first problem of the weekly contest, which is quite simple, right? The time complexity is of n log n, because we have using for sorting and we didn't have any use any extra space, so it's so fun. So yeah, that's the first problem. Let's move to the second problem. It's quite interesting. I uses a different approaches to solve this particular problem. I thought use map and a lot of other stuff. Then I got to realize, okay, don't complicate it, just straight to the problem statement and try to come up with a solution. So what the problem saying is, it's a little descriptive, that okay, you are given an integer array parent of n representing the rooted tree with a node labeled from 0 to n minus 1. The tree is rotated at node 0, so the node 0 parent is minus 1. Got it? For each node I, where I is less than n minus 1, parent I denotes the parent of the node I. Okay, we are also given an integer array nums of the length n, where nums I denotes the value of node I. Got it? The weight of node I is at depth d is nums of I multiply height minus d plus 1, where h is the height of the tree. Got it? Return the sum of the weights of all the node inside the tree. Then how to calculate the depth? Like, what's the depth? Depth of the node is the number of nodes on the path from the root to that node inclusive, with the root having depth 1. The height of the tree is the maximum depth among all nodes in the tree. So this is the parent which we have given, and this is the value. So what's they are saying, that just pick it over from here. So this is the value which we have right now. So what they are saying, that if you read this particular statement, that it's a tree rooted at node 0. So parent 0 is this one, not this one. The thing is that so let's do indexing 0 1 2 3 4 5. So what they're saying, that parent I represents the parent of ith item. So this is the main meaning about parent I. What does this particular value represent, and what does this particular value represent? Which means the parent of 0 is minus 1, because there is no parent for 0, right? For the parent of 1 is 0, for the parent of 2 is 0, for parent of 3 is also 0, right? For the parent of 4 it is 2, and the parent of this is 4, not 2, parent of 5 it is also 2. So this is what it will be actually referring. So let's try to draw a tree with this. So we have, let's say, this node. Got it. So one node here, one node here. It is possible if I can just copy it from here. No, it's an image. Got it. So let's try to make it. So this is, let's consider it as a tree. I know my drawing is not good at this point of time, but it's just a tree. Let's just write the value. So this is our 0th node. This is our this is our third node. This is our second node. This is our first node. This is our fourth, and this is our fifth node. So I can also use this one. Just a second. So let's draw it for a better visual understanding, right? So this is basically the nodes which we have. I'm just making drawing a little bit better to understand it for the better, right? And this represents, so this one is our root node, which is 0. This is 1, this is 2, this is 3, this is 4, and this is 5. So this is the tree actually look like when we actually use this particular provided value. So that's the tree is actually look like. So what's if we just calculate the height and depth from here? So what's the height? So what's the height? Height is the maximum depth from all the available node from the tree. So the height of this particular tree is 3, if you can see, right? And for the depth we have to calculate it for the root node to till that particular node. So for the one for this particular node, if we calculate, so for this for the one, the depth is 2, because in the problem statement they have clearly mentioned that for the root node the depth is 1. If you see yeah, the node, the value there is the root having the depth of 1. So this is the statement. So right, so just I know it's get little weird, but yeah, this is the core thing, that okay, this is represented as in this particular format where each value represent like this, right? So the idea is, what we have to achieve is we have to calculate the depth at each node, and we have to return. In order to calculate the depth, we should use this particular formula. So the thing is, how we can get so what are the major problem which we need to take care of, that how to find depth. So this is the one thing, and how to calculate height. So this is another thing. So we just need to take care of these two things. If we are able to find this, then everything become easy for us. So as you see, we don't have a direct tree given here, but we have a structure of tree given with the help of this particular array, with the help of this particular value. So we will use it. So instead of creating a tree, why shouldn't we use a graph structure? Because we have a node which is pointing to each other, right? So we will create a graph where we will write a, I will just write a value, how we actually store inside a like graph. So for the 0, what are the neighbor nodes? 1, 2, 3. For the 1, there are no neighbor nodes. For 2, there are 2 neighbor nodes, or you can say child nodes. 4, 5. For 3, there are no nodes, and for 4 and 5, there are no nodes. So now we have created on this particular decentralized list, you can say, right? Now we have to do these two things. So in order to do this, we can use DFS or BFS. So I will use DFS over here because that is look more intuitive for me and more easier for me at this point of time. So I have to calculate the height. So what will I do? I just simply go to the depth. If I'm at this particular index, then I go to the depth till this point and this point and find what is the maximum depth at this point and iterate from root to all other nodes available out there, right? And in order to calculate the depth, what will I do? So just a standard, like while moving from just change the color. So just moving from here to here, if I'm at initially at root, then the depth is 1. Now when I'm calling their child or neighbor, then I just increase the value of depth as +1, depth +1, so that when I reach this particular node, so when I reach this particular node, then the value becomes depth +1. So I think it's more intuitive to see over the code. So what I have done, so this is the array list which I have created, right, to store the tree in the form of graph. And after that, what I have been doing, I'm just creating a graph. This is the case because the root node do not have a parent and we cannot use -1 as index. So that's why I'm just not considering it inside the answer. After that, I'm just calling on get height function from the root node. So what this function is actually doing, so this is the height. So I'm running towards all the child node and calculating the max height, because you know what's the definition of height, that the height of the tree is the maximum depth among all the nodes in the tree. So that's what I have been doing over here, and I'm doing it DFS over here and recursively finding the result. What about the depth? For depth, I'm starting from the 0, then I have created an array so that for the ith node I know what's the depth, because in case of height, overall nodes are going to use that, but in case of depth, every node has their own depth, right? So that's why I have created a depth. And now what's the initial depth, right? And whenever I'm reaching at any node, I'm just assigning the depth value which I am currently carrying. After that, I'm moving towards all their childs, and whenever calling, I'm just increasing the depth value as 1. So that's how I'm calculating the depth. So this is the most important part of this particular problem, how to got these values. After that, it's simple. Why I've been doing +1, because we are not including first node as well. We are calculating from 0 to the rest of the node, but we also need to calculate 0 as well. So that's why I'm doing +1, because I also need to include root as well. After that, I have created a depth, iterating over my nums array, you can say, and I'm just applying the formula, because depth I represent the depth of that particular node, height is common for all the nodes, and nums I the current value of the current node, and storing inside the result and just returning it from here. So this is the second problem. I think if you didn't able to understand, do try to watch the video again. Maybe it become a little bit weird while explaining the question because it's too much theoretical, but yeah, question is pretty simple, pretty straightforward. You just need to know about few techniques, and I think you know if you have done a lot of problem related to graph and trees, even if it's a basic graph and tree problems. So this is about the Twitter contest, and I hope you able to understand them, and I hope you like the video. If you, then do let me know in the comment section. Do like the video and do share with your friends. Do subscribe to the channel, and until then, bye bye and take care.